Okay, this is a graph sketching. We've got y equal this function involving e's. So you need to start by remembering what the graph of y equals e to the x looks like. Looks like it's not very easy to help you with this without doing it for you. Alright, it's a exponential increased graph, okay, and it's got a y-intercept, which I'm not going to tell you what it is, but you should be able to know what that number is, and you should know the equation of this asymptote. And we've got to find out what happens when we change it into this. So you can see there's a +1 going on, there's a +2 going on, okay. Think about whether they're inside or whether they're outside. Think about the transformations we get of the graph. So think about whether you have to do any stretching or translating, okay, and then think about whether that stretch or translation will affect the position of the asymptote. So the asymptote was initially y equals 0. If you stretch away from the x-axis, then that won't affect the asymptote. If you stretch horizontally, that won't change the asymptote to begin with. Okay, but if you translate up or down, that will affect the asymptote. Translating sideways won't. Okay, so you need to decide what will happen to the asymptote, and you also need to think about what happens to this point. Now, it says that we want the asymptote, so we've transformed our asymptote. This y-intercept may not, after transformation, be the y-intercept anymore. So for any graph, you know that the y-intercept will be when x equals 0. So into this function, you can substitute x equals 0 to get the y-asymptote, the y-intercept on your graph. And in fact, the image of this point after it's been mucked around may not actually be something you have to include, but you won't get marked down if you do, as long as you have the y-intercept as well. Hope that helps.